Hey guys, welcome to another video for Falcon's Biology. We're taking a look at urine formation. How does the body get rid of these waste products that it produces? So every single cell in the body is doing work. It's kind of like in your home. Every single home in your neighborhood is doing work. And every couple of days, if not every day, trash is coming out because you don't want trash to accumulate in a house. Otherwise, it gets really stinky and pests and all that stuff. So likewise, every single cell in the human body is producing waste products from cellular respiration and what have you. And that waste product has to get eliminated. Otherwise, it builds up, those toxins build up, you get sick, diseases happen, and so on and so forth. So, where, or one of the places where these toxins gets filtered out and eliminated is in the kidneys. We've already talked about the digestive system. Now we're looking at the urinary system, and we're going to zoom in here. And we have here the cortex and the medulla. Now let's go in even deeper into that and look at the nephron. So the lighter pink at the top is the cortex, and you see these features, these little these tubes that are intertwined and curled up on each other, and then you see a little ball there with a red ball on the inside. That's what we're looking at. And then if you follow it down, you see that really thickish beige tube that is going all the way down at the very bottom to the renal pelvis, and that's where you're going to get your urine to get eliminated into the bladder. But let's focus in on these nephron tubes right here, as I mentioned before. So again, at the top is the renal cortex, and then the darker pink at the bottom is the medulla. Now, you're going to notice here, I'm going to make one of them thicker because it technically is thicker. These are the arteries that are going in what's called the glomerulus. So that little ball that you see on the inside there, it's kind of hard to explain, but if you look at it in a microscope, it looks like a ball of yarn. All those are capillaries. These are microscopic arteries that are balled up inside what's called a Bowman's capsule, and that's that beige part circle that's covering up the glomerulus. Now, going to the glomerulus is a thicker blood vessel, and then you notice that it gets thinner. That's actually really important because that produces, I'll talk about that in more detail in a few slides, but that produces a pressure gradient. It produces pressure, kind of like a water hose like we discussed in class. If you put a nozzle on it and you reduce the diameter of the opening, it produces a spray. It produces high pressure, and that is exactly what's happening in here. That high pressure will force toxins out. It will force toxins out of the blood and into the Bowman's capsule. So here we go. So the blood is coming from the artery, and then the toxins are going to be forced out at the glomerulus, and they will go in to the Bowman's capsule. And there, those toxins will build up, and it goes through the nephron tube right there, and then it's going to go to the distal convoluted tubule, and then the collecting duct, and then down into the renal pelvis. So let's highlight each of these sections as I was mentioning before. So again, first is the glomerulus, that reddish, encapsulated in the Bowman's capsule. Okay, this is the first phase in filtration. This is the glomerular filtration, where the toxins are forced out by pressure into the Bowman's capsule. And then the next stage is called the proximal convoluted tubule. Here what we call a reabsorption, tubular reabsorption, meaning that the blood vessels, now that's another thing. Notice how all of these tubes there's blood vessels that are surrounding them, covering them, because there's still more filtration to happen throughout this whole process. With the exception of the collecting tubule, you notice the collecting tubule doesn't have any blood vessels around it, but all the other parts do. So back to the proximal convoluted tubule. Now remember, proximal means close. So what is it close to? It's close to the glomerulus, the Bowman's capsule. So this is the proximal convoluted tubule, the one closest. Here we have still some useful products. We have amino acids, glucose, we have some salts, some electrolytes that the blood still needs. And so here, they will be reabsorbed back into those blood tissues. They exchange hands. And then the next stage is the loop of Henle, or the nephron tube. Now there's a lot to be said about this, but I'm going to leave that out. Do know what it is, but don't worry about what it's reabsorbing and what it's secreting. In fact, let me talk about those two terms. To absorb something is to take in. So going back to this, what's the thing that's taking in? The blood vessels. So we're looking at this from the perspective of the blood vessels. Going back, here you're secreting waste products. They're leaving the blood vessels. Here you're reabsorbing nutrients that were ejected in this previous stage. So not only did waste products get kicked out, but some products that we still need, and they get reabsorbed right here in the proximal convoluted tubule. So they go back into the blood, the good stuff. But all the bad stuff, the waste products, stay in that tube, and slowly but surely, urine is being produced, the waste product. And then, of course, like I mentioned, you have the loop of Henle, or the nephron tube. And then here at the end, you have another tube that is convoluted. It's all tangled up. This is called the distal convoluted tubule because it's the one furthest away from the glomerulus. At the distal convoluted tubule, you have what's called secretion, tubular secretion, meaning that at this stage, at this latter stage, there are still blood vessels that still have some toxins or waste product that they didn't get rid of previous. And here they get rid of it. So your blood vessels will get rid of toxins, okay? They'll get rid of it and they will go into the renal tubule, the nephron tube. And eventually all that urine gets collected and ejected through the collecting duct. And that goes down into the renal pelvis where it gets collected and then taken down the ureter and into the bladder. Again, glomerular filtration, waste products out, tubular reabsorption. Okay, so the blood still has that urine that still has some good products that go back to the blood vessels. Okay, the nephron tube, the loop, and then tubular secretion, meaning the blood will now eject more waste product, so it's getting cleaner, more purified, and it goes into the renal tubule, and then finally into the collecting duct down into the renal pelvis. Okay, so down the collecting duct into the renal pelvis, as I mentioned, and those collecting ducts run all the way down the medullas, okay, those dark pink ones, they run all the way down the medullas into the renal pelvis, where they get collected, and that's where the urine gets collected, and then evacuated down the ureter and into the bladder. So going back to what I mentioned before with that really thick artery, so the diameter of that artery is larger than what's inside the glomerulus. And that change in diameter is what causes the high pressure. And that high pressure is what forces the waste products out of the glomerulus and into the Bowman's capsule. So I just thought I'd give you a quick little image there. Okay, I think that does it for this video. I hope this helps. Good luck in your studying.